So carrying on from the last lesson, something I didn't mention, which was probably quite important, is why it's called the cast diagram. You've probably figured this out already, but basically it's because the letters in it spell out cast. C-A-S-T. Okay, there's other abbreviations for using it, but I've always called it the cast diagram, so I'm going to stick with that. Another thing that is useful to remember is that, see, I've put in these little equations at the top here. You might have seen them before. It's like 180 minus, 180 plus, 360 minus. So the thing is, what you've got to think about here is whether you're trying to figure out the principal angle or the relative acute angle, okay? So if I say to you, okay, what's the relative acute angle for 100 and for 200 degrees, maybe, okay? So you'd have to go, okay, 200 degrees, that'll be in this one here. Okay, so what's the difference between 200 and, well, 200 would be down here, wouldn't it? 200 and 180, so the relative acute angle would be 20 degrees, right? And sometimes these are really helpful for shorthand, figuring things out, but I find you're always best just to draw a sketch and think about it realistically, because it's not like a hard file rule, because here you're working out principal angle, whereas here you might sometimes want to know the relative acute angle. So you really need to be careful in what it is that you're trying to figure out. So I'm going to go on and do some examples, and hopefully that makes things a bit clearer. So if I say to you, okay, I want to find the exact values of 300 degrees, okay, how do we go about doing this? Well, the first thing you always do is draw out a little sketch of the cast diagram. It's literally as simple as doing C-A-S-T. Okay, so the first thing you want to think about is, where is 300 degrees on this graph, or in this quadrant? Well, 300 degrees is bigger than 270, less than 360. So it's in here, right? And what do we know about the sign of this? Well, we know that for sine is positive in the first and second, so it's going to be positive. So it's going to be negative here. Okay, so we know this. First of all, it's going to be a negative value. And now, when we get the what we wanted to figure out is the acute angle, because the acute angle tells us, like, you can almost think of it as the height or the magnitude of the value, whereas the quadrant it lies in will tell us the sign of it, whether it's positive or negative. So we can see here that this is 300, and we want to figure out what the difference between there to the horizontal is. Well, we can just see there it's 60 degrees. So our answer here is going to be equal to sine 60 degrees. So our final answer is minus sine 60 degrees, right? 60 degrees, we know from a triangle, is root 3 over 2 and minus. So that's our answer there. Okay, but what if we're given a negative angle? All right, a negative angle. So again, you want to really draw out your cost diagram and get really comfortable doing this. Right, so negative angle, so positive angle you measure this way, negative angle you want to measure the opposite way. This would be negative 90, this is negative 180. So negative 135 is going to appear somewhere in here. Okay, negative 135. Okay, so you can think, okay, how many degrees is it between this here and this angle here? It's going to be 45. So we've figured out our acute angle here. But what we also need to figure out is our sine, because this is cos. So we're saying, what is cos of a negative 135 degrees? So we know it lies in this quadrant, but what we're saying here is it would have been positive there and there, but it's actually here. So it's going to be negative, right? So it's going to be negative cos 45, right? So I know this might seem confusing because you've got a negative value here, and you think, okay, negative, negative, positive, but it doesn't not really work like that. It's the same as saying you could have cos 225, which is the same as the complementary angle. If you go, I'll change color. If you go the other way, that's 225, and then this little angle here is 135, and that adds up to 360. So we've got cos negative 45, which we know is going to be, that's red, negative 1 over root 2. And we know that for triangles. Okay, so what about this example here? I want to know what cos negative 2 pi over 3 is. So you may be thinking, okay, this is not degrees, this is confusing. It's exactly the same, except you're using radians. So this is pi over 2 here, this is pi, this is 2 pi over, 3 pi over 2, oh, about 3 pi over 2. And what you need to think is, okay, I've gone from here, I'm going to go back 2 pi over 3. Okay, so 2 pi over 3 is 1/3 away from being pi. So so it's gone back almost to here, right? So we know it's here somewhere. So we can say that is 2 pi over 3. So we want to know what this angle in here, what the relative acute angle will be to get back to the horizontal. Well, it's just going to be 1/3 pi in here, pi over 3, and that will get you back to horizontal. So what we really want to know is going to be, we know it's going to be, we didn't even write the things, CAST. So okay, we can see that it's appearing in the third quadrant, and cos is not positive in that quadrant. So it's going to be negative, and it's going to be cos negative pi over 3, right? So the final answer, we know that pi cos 30 is a half, cos 60 is a half, and that's the equivalent to pi over 3. So this is going to be negative 1 over 2. So this may seem a bit confusing, but the more you get used to it, the more you try to like memorize different things and just try and use the quadrant and understand what each place means, it becomes a lot simpler. So remember that the position in the angle just gives you the positive or negative, and then the acute angle will give you the height or the size, the magnitude, whatever you want to call it. Okay.